Quantitative ability, probability. Well, I feel before going through this topic, anyone should first go through a topic called permutation and combination, whose link is available in the description box. What is probability? The word probability means chance, or in a broad sense, it is expressed as a possibility that a particular event may occur. How probability is expressed? It is expressed in ratio. If it is expressed in ratio, then what comes in numerator and what comes in denominator? Well, in the denominator, it is total possible occurrences. And out of that total possible occurrences, how many are favorable to us, that we put in the numerator. So probability of any particular event is favorable occurrences divided by total possible occurrences. Let us understand with a very simple example. If a coin is tossed, what is the probability of getting head? So if we are tossing a coin, there are only two possible occurrences. Either head will appear or tail will appear. Out of which, if we want head, so in our favor there is head. So the probability is 1 out of 2. If two coins are tossed, what is the probability that both the coins show head? When we are tossing two coins, our total possible occurrences are 2 square, that is 4. Either head head will appear, or tail tail will appear, or head tail, or tail head. So we want that both the coins show head. So out of 4 possibilities or occurrences, one is favoring us. Hence the probability becomes 1 out of 4. Let's go with the third example, where it is asked, if 5 coins are tossed together, what is the probability of getting number 1 exactly 2 heads, number 2 at most 2 heads, and number 3 at least 2 heads. We'll go with the first part, exactly 2 heads. Now when we are tossing 5 coins together, our denominator will be 2 to the power of 5. Even if we toss one single coin for 5 times, our denominator will be 2 to the power of 5. Those are called as total possible occurrences. Now what we want exactly 2 heads. So there are total 5 heads available in 5 coins, out of which the number of ways in which we can get any 2 heads is 5C2. So the probability becomes 5C2 divided by 2 to the power of 5, and solving this comes out to be 10 out of 32. Coming to the second part, at most 2 heads. At most 2 heads means maximum 2 heads. So even if we get number of heads less than 2, it is permitted. So this probability is equal to probability of getting 0 head, or exactly 1 head, or exactly 2 heads. So solving this, that is equal to 5C0 plus 5C1 plus 5C2 divided by 2 to the power of 5. I have already told in the video of permutation and combination that whenever the word and comes, we should do multiplication, and whenever the word or comes, we do addition. So solving this comes out to be 1 plus 5 plus 10 by 32, which is equal to 16 out of 32. So the probability of getting exactly 2 heads is 10 by 32, and at most 2 heads is 16 by 32. Now coming to the third part, what is the probability of getting at least 2 heads? Kam se kam 2 heads. So again the denominator will be 2 to the power of 5. So this probability is equal to probability of getting 2 heads or 3 heads or 4 heads or 5 heads, because the word used is at least, do ya do se zyada. So solving this comes out to be 5C2 plus 5C3 plus 5C4 plus 5C5 divided by 2 to the power of 5, which comes out to be 26 out of 32. Well, this particular part can be also solved by alternate method as like this. The total of all the possibilities or probabilities is equal to 1. So from 1, we can subtract the unwanted probabilities. What we do not want that number of heads coming less than 2, that is 0 or 1 head. So from 1, we will subtract those two possibilities. So solving this, it comes out to be like this, and the final answer will be same, like 26 by 32. Let's take example of a dice. A pair of dice is rolled. What is the probability that both will show the same number? So when we are rolling one single dice, our total possible outcomes are 6. But when we are rolling a pair of dice, our total possible outcomes will be 6 square, so called 36. Now out of these 36 combinations, how many are favoring us which are showing the same number? There are 6 combinations which are favoring us. That is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. So out of 36, 6 are favoring us. So the probability becomes 6 out of 36 or 1 out of 6. Let's take a next example where it is asked a pair of dice is rolled. What is the probability that sum of the number on the two faces is less than 9? Well, what we will do here, we will find out all the combinations which are giving the sum as 9 or more than 9, and those combinations or possibilities we will subtract from 1. So the remaining probabilities will be those where we get the sum as less than 9. So exactly 9 sum, we will get 4 possible combinations. First dice showing 4, second showing 5, or first showing 5 and second showing 4, or 3 6 or 6 3. So there are 4 possibilities which are giving us sum as 9. Similarly, we will get sum as 10 by following 3 combinations, either both showing 5 5 or 4 6 or 6 4. Sum will be 11 by 2 combinations, 5 6 or 6 5, and sum will be 12 only if both the dice show 6 6. So these are all combinations which will give sum as 9 or more than 9. But what we want that sum of the number on the two faces is less than 9. So from 1, we will subtract all these possibilities which are giving us sum as 9 or more than 9. So if we subtract this, there are total 10 combinations. So 1 minus 10 by 36, remaining 26 combinations out of 36 will give the sum as less than 9. Addition theorem on probability. Well, if there are two events A and B, and if I want to say the combined probability of both the events, that is probability of A union B, it will be equal to probability of event A plus probability of event B minus probability of A intersection B. Means whatever is common between A and B, that we subtract. The events in the probability are categorized as mutually exclusive events or independent events. Now, what are mutually exclusive events? These are the events in which occurrence or non-occurrence of one event affects the occurrence or non-occurrence of other event. So they are dependent on each other. And what are independent events? These are the events in which occurrence or non-occurrence of one event does not affect the occurrence or non-occurrence of another event. So in case of mutually exclusive event, probability of A intersection B will be equal to 0. Let's take an example. Suppose if I toss a coin and if I ask you what is the probability that head will appear, it is 1 out of 2. What is the probability of tail will appear? It is 1 out of 2. So if head will appear, it will not allow tail to appear or vice versa. So occurrence of one event affects the non-occurrence of some other event as they are mutually exclusive. In case of independent event, the probability of A intersection B will be probability of A multiplied by probability of B. Let's take an example. If I suppose toss two coins together, and if I ask you what is the probability that first coin show head and second coin show tail, they are independent event, because what is appearing on the first coin has nothing to do with what is appearing on second coin. It won't affect what is appearing on the second coin. They are independent events. Here we take product of probabilities. Let us understand this with an example here. There are 20 tokens numbered from 1 to 20. If one token is drawn at random, then what is the probability that the token has a number which is a multiple of 2 or 3? So multiples of 2, there are 10 favorable numbers which are all even numbers, 2, 4, 6, 8 up to 20. Multiples of 3, there are favorable numbers 3, 6, 9, 12, 15 and 18. 6 favorable numbers. Now, what is asked? The probability that the token has a number which is a multiple of 2 or 3. Means we want to find out the probability of A union B. So we will apply this theorem here like this. So there are 10 numbers which are in favor, which are all multiples of 2. There are 6 numbers which are favoring us, which are multiple of 3. But there are 3 common numbers, so called A intersection B. Which are those? 6, 12, and 18, which are considered in this 10 also as well as in this 6 also. So those three commonly repeating numbers we are subtracting. So the probability comes out to be 13 out of 20. Example 7. From a box containing 6 bulbs, of which exactly one half are good, 2 bulbs are chosen at random to fit in 2 bulb holders in a room. The probability that room gets lighted is. So out of 6 bulbs, 3 bulbs are good and 3 are non-working. So I will say that the room will get lighted if at least one bulb is good. So here we need to find out the probability of getting at least one good bulb. So this probability will be equal to the total of all probabilities, that is 1 minus probability that both bulbs are not working, which we don't want. So if you are selecting any 2 bulbs out of 6 bulbs, the total possible outcomes will be 6C2, and favorable outcomes that both bulbs are non-working is 3C2, because 3 bulbs are non-working and we have to choose any 2 out of that. So this will be equal to 1 minus 3C2 divided by 6C2. Solving this, the probability comes out to be 4 by 5. Example 8. A basket contains 6 red and 4 green balls. 2 balls are picked at random simultaneously. What is the probability that? Well, I will put 4 questions in front of you, but I will underline here the word simultaneously, because these balls are picked together. The first question is both are red, second is both are green, third is both are of different color, and fourth is both are of same color. Let us go with the first part. What is the probability that both the balls that are selected simultaneously are red in color? So out of 10 balls, if I am picking 2 balls at random, my total possible outcomes will be 10C2. That is my denominator. And how many balls are red which are favoring me? There are 6 red balls, out of which I want any 2. So this is equal to 6C2. So the probability that both will be red will be equal to 6C2 divided by 10C2. Coming to the second part, what is the probability that both will be green? Obviously this will be equal to 4C2 divided by 10C2. Number 3, what is the probability that both are of different color? Means here I want one ball red and other ball green. So this is equal to 6C1 into 4C1. Out of 6 red ball, I want any one red ball, and out of 4 green balls, I want any one green ball. As the word and I am using here, so there will be multiplication. Coming to the fourth part, what is the probability that both are of same color? Means either both red or both green. So this will be equal to 6C2 or means plus 4C2. So these are the answers of these 4 questions when both the balls are picked simultaneously. Next example, where again there are 10 balls, out of which 6 are red and 4 are green. If 2 balls are selected successively, then what is the probability that they will be of different color? If now here I will underline the word successively, because in this case we are picking the ball one after other, we are not picking it simultaneously. So these becomes 2 independent events. Okay, so the question is, what is the probability that they will be of different color if? Number 1, first ball is replaced. Means we have picked the first ball, seen the color of the first ball and replaced it back. So when we are picking the first ball out of 10 ball, let us say the probability that it will be of red color is 6 out of 10. Now we have seen the color of that ball, we have kept it back in the basket. And when we are picking for the second time, it will be green color. The probability is 4 out of 10. So as they are independent events, we take product of probabilities. First red and second green. So 6 by 10 multiplied by 4 by 10. Hence the probability will be 6 out of 25. Second condition, that they are picked successively and they will be of different color if first ball is not replaced back. Means we have taken the first ball, seen the color and kept it aside. We are not putting it back in the basket. So first ball it will be of red color is 6 out of 10 probability, and when we are picking for the second time, now there are only 9 balls left in the basket. The probability that it will be green color is 4 out of 9. So the resultant probability is 4 by 15. So there are two cases as we have discussed in example 8 and example 9. Either the ball can be picked simultaneously or the balls can be picked successively. If they are picked successively, this becomes independent events. Example 10. If the letters of the word articles are arranged at random, then what is the probability that all the three vowels will be together? Now, article is a 7-letter word. So, these 7 letters can be arranged among themselves in a total of 7 factorial ways. This is seen in permutation and combination. So total possible occurrences are 7 factorial. Now what we want that all the 3 vowels should be together. So let us club these 3 vowels and consider this as one single unit. Remaining 4 consonants can be considered as 4 individual units. Now there are total 5 units which can be arranged in a total of 5 factorial ways, and these 3 vowels can be arranged among themselves in 3 factorial ways. So the favorable number of occurrences will be 5 factorial into 3 factorial. So the probability that all the 3 vowels will be together when we are randomly arranging it is 5 factorial into 3 factorial divided by 7 factorial, which comes out to be 1 out of 7. Example 11. 6 persons are seated in a row. Probability that 2 particular persons A and B are seated at the end. So if there are 6 persons from A to F, they can be arranged in a total of 6 factorial ways, which are the total occurrences. Now what we want that 2 particular persons are always seated at the end. So A and B are sitting at the end. The remaining 4 persons can be arranged in between the 4 places in a total of 4 factorial ways, which I will say are favorable occurrences. So the probability, resulting probability will be 4 factorial divided by 6 factorial, that is 1 out of 30. The problems on playing cards is a significant portion of probability. So in a pack there are total 52 cards, out of which 26 are red and 26 are black. Now when we do the bifurcation of these red and black cards, there are 13 heart cards, 13 diamond cards, 13 spade and 13 clubs. So there are 4 suits. In every suit we have 4 honor cards, that is ace, king, queen and jack. Okay, out of which king, queen and jack are called as face cards, and card number 2 to card number 10 are called as numbered cards. Example 12. A card is drawn at random from a pack of 52 cards. What is the probability that the card is a numbered card or a red card? So there are 9 numbered cards in one suit and there are 4 suits in a pack. So the numbered cards are total in 36, which are favorable occurrences. Now talking about the red cards, there are 26 red cards. Now there are some common cards which are numbered also and red color also. How many are these? These are half of 36, which are 18. So numbered red cards are 18. So if I want to find the probability of A union B, it is equal to probability of A plus probability of B minus probability of A intersection B, which is common. So these 18 numbered red cards are considered here also in this 26 as well as considered in this 36 also. So as it is considered double, we need to subtract it. So this is equal to 36 plus 26 minus 18 divided by 52, which comes out to be 44 by 52 or 11 out of 13. Example 13. When 4 cards are drawn in succession from a pack of 52 cards with replacement, what is the probability that all the cards are from different suit. Here, one point to understand is the 4 cards are drawn in succession, means one after other. So they become 4 independent events, and the replacement is done. Means every time when you are picking a card, there are again 52 cards in the pack. So what is the probability that all of them are from 4 different suits? So the probability that the first card that we are drawing is of spade is 13 out of 52. We have replaced it back. Probability that the second time we are drawing is of, let us say, heart is 13 out of 52. Third time when we are drawing, it is again 13 out of 52, and the last card is of heart is again 13 out of 52. So the probability is 1 out of 256. Let's take some other example here, where it is asked, what is the probability that a leap year selected at random contains 53 Sundays? When we talk about a non-leap year or an ordinary year which has 365 days, if I divide it by 7, I get 52 weeks and one remainder, that extra day we get. This extra day can be anything. It can be Sunday, it can be Monday, it can be Tuesday, it can be Wednesday, anything out of the 7 days. So the probability that specifically that extra day is a Sunday is 1 out of 7. Because already we are getting 52 Sunday, 52 Monday, 52 Tuesday, everything, as there are 52 weeks here. So that extra day will be specifically only Sunday is 1 out of 7. Now when we talk about a leap year which has 366 days, if I divide 366 with 7, I get 52 as a quotient. So there are 52 weeks and the remainder left out is 2. So there are 2 extra days. Now the probability that out of these 2 days, any one can be Sunday is 2 out of 7. Example 15. A speaks the truth in 60% of the cases while B speaks in 80% of the cases. What is the probability that they will contradict each other in stating the same fact? Now in this case, the probability of A speaking the truth is well mentioned, that is 60% or 60 out of 100 or 3 out of 5. So the probability of A not speaking the truth is 1 minus 3 out of 5, that is 2 out of 5. In a similar way, probability that B speaks the truth is 80%, that is 80 out of 100 or 4 out of 5. Probability that B is not speaking the truth is 1 out of 5. Now the question is, what is the probability that they will contradict each other in stating the same fact? This will happen if A is speaking the truth and B is not speaking the truth, or A is not speaking the truth and B is speaking the truth. So we need to substitute here the respective probabilities. So probability of A and means I will do multiplication, and probabilities B is lying, plus, or I will replace by plus, probability that A is lying multiplied by probability that B is telling the truth. So substituting the respective values, we can calculate the probability, which comes out to be 11 out of 25. Hope with this video you have understood the concepts of probability. Thank you for watching this video.